Good evening, children.
Good evening, ma'am.
Good evening. So where did we stop in the last class, children? We got this quadratic equation, right? X square minus, no, I think plus 34x. Yeah, minus 672, I think, is equal to 0, right? Did we solve this equation? Okay, so let me do it now. Did we finish this one, children? Let's not waste time.
Yes, ma'am, we completed this one.
We completed. We found the perimeter.
Yes, ma'am.
Oh, okay, fine. What's the question number now? 9?
It's actually 8, ma'am.
8, okay. So at first, just make a rough diagram like this. That is, we'll make 2 diagrams. The rough diagram itself will make 2. First, we'll just draw, something that looks like a square or a rectangle, and fill the information given there. So simply, draw a rectangle or a square, A, B, C, D. Okay, what is given? Find the area of a quadrilateral ABCD in which AB is equal to 9 centimeters. AB is 9 centimeters. BC is equal to 40 centimeters. BC is 40 centimeters. CD is 28. CD is 28. And DA is 15 centimeters. And the angle between the first 2 sides is a right angle. Now, when we call the quadrilateral ABCD, the sides in order are AB, BC, CD, and AD. So these are the first 2 sides. These are the first 2 sides. The angle between the first 2 sides is a right angle. The angle between AB and BC. So this angle is a right angle. Now, children, this is not a rectangle. Uh, I've just drawn a rectangle to just fill the information given. All right, now don't say it's a rectangle, so everywhere it is 90 degrees. No, I've just taken a rectangle to fill the information. Now, only this is 90 degrees. The angle between the first 2 sides, AB and BC are the first 2 sides. The angle between AB and BC is a right angle. Is a right angle. Now, let's draw the real rough figure. Okay, this is kind of a fake rough figure. This is a fake one. Now we'll draw the real rough figure. Okay. I'll do it here since I don't have place in the rough column. I'll do it here. Now see, just, like kind of, I can say predict or estimate the figure. You need not draw the accurate one. You cannot draw the accurate one. The accurate one you can get only by construction. Only when you construct, using a pair of compass and a scale, you can get the actual diagram. So now you just have to estimate the figure. So AB is like, say like this. BC is a right angle and it's longer than AB, no? So let's make it bigger like this. Okay, it's longer. So let's make it bigger like this. Then CD, you can see AD is again 15 centimeters. So maybe like this. See, it's a rough figure, children. AD like this, and then CD like this. I'm trying to convey something. Is it okay? No, okay. So see here, AB, this is AB, this is AB. Okay, AB is 9 centimeters, 9 centimeters. Then let me draw it here. Let me draw it here, children. So AB is 9. So like this, AB is 9. Then BC is 40. BC is 40. And the angle between the first two sides is the right angle. So it's 90 here. This AB, which is 9 centimeters. And this is BC, which is 40 centimeters. Okay, this is C. Now, how much is CD? CD is 28 and AD is 15. So AD is pretty short, like small. So AD, so maybe I'll do it like this. AD is 15. This is 15. Let's make it a little longer. I think since you all know you've started working, you're not listening to me, I think. Okay, AD is 15 centimeters. And then CD is 28. So let's join CD like this. CD like this, 28 centimeters. Yes or no, children?
Understood, ma'am.
Yeah. Yeah, first simply take a square or a rectangle, fill the information given. Fill the information. Now using this, make the real rough figure. I told you this is the fake one. This is a fake rough figure. This is the real one. This is the real rough figure. The rough figure can vary, between two students. Not all of us should have the same rough figure. A rough figure, as the name says, is a rough figure. So when you construct it, actually, it may look completely different. So that's a different thing. Okay, now, so we are now going to use this figure, this is the rough figure. We're going to use this one. This is the rough figure. Okay, ignore this. In the exam, you may erase this. Draw this with a pencil. Draw this one with a pencil and you can erase this one. You can erase this one. All right, now, yeah. So now we need to find the area of this quadrilateral ABCD. Now we have this Herons formula to find the area of a triangle. And we have other formula also to find the area of a triangle, half base into height, root 3 by 4a square. We also have Herons formula. So now we do not have a formula to find the area of any quadrilateral. Meaning, see, there is a formula to find the area of a quadrilateral, but for that we need to know the altitudes on the diagonal. So here we do not know the length of the diagonal or the altitudes on the diagonal, so we cannot use that formula. So since we only know the areas of triangles here, we'll join one of the two diagonals. We'll either join AC or BD. Now we'll have to decide which one to join. Now if you join BD, you'll disturb the right angle. If you join BD, you're disturbing the right angle. You're disturbing the right angle. So don't join BD. Don't join BD. Because if we join BD, see, the thing is you'll have to join any one of the two diagonals to get two triangles. Now, which diagonal to connect? Do not connect BD because you'll disturb the right angle. So join AC. Connect AC. Connect the diagonal AC. Now, when you connect the diagonal AC, the whole quadrilateral is divided into two triangles. Two triangles. So this one ABC is a right triangle and this one is a triangle, maybe a scalene triangle. So the area of this right triangle you can find using the formula half base into height. The area of the scalene triangle can be found using Herons formula. Okay, so let's first find the area of triangle ABC. So area of right triangle, see here RT, right triangle ABC. is equal to half base into height. Half base into height, square units. So that is half into base is AB and height is BC. So half into 9 into 40. So 29, so 180 centimeters square. Now we need to find the area of triangle ADC or ACD. So for that we need to find AC. So an AC can be found using Pythagoras theorem. So in right triangle ABC, by Pythagoras theorem, AC square is equal to AB square plus BC square. Why we are using Pythagoras theorem in triangle ABC? We can use Pythagoras theorem only in triangle ABC. You cannot use it. Now, we might think why we can use Pythagoras theorem in ADC and find AC. In ADC, see, we might think.
It's not possible because it's not a right triangle.
Yeah. So if you feel, why not use Pythagoras, theorem in triangle ADC and find AC? The answer is exactly what Madhumita said. ADC is not a right triangle. We cannot apply Pythagoras theorem in any triangle. It should be a right triangle. So which one is a right? So you can find AC maybe using ADC if it was a right triangle. So Pythagoras theorem can be applied only in a right triangle. So ABC is a right triangle, and using that, we apply Pythagoras theorem and find AC. So AC square is equal to AB square is 9 square plus 40 square. So AC square is equal to 81 plus 1600. AC square is equal to 1681. AC is equal to square root of 1681. AC is equal to 41 centimeter. AC is equal to 41 centimeter. Now we have to find the area of the other triangle ADC using Herons formula. I think that you can do. Please work, children. Write down the answer so far and calculate the area of triangle ADC using Herons formula. And this one, children?
No, ma'am.
Okay, please write. Yeah. Yes, children, is this over?
Yes, ma'am.
Yeah.
Yes, ma'am.
I'll let you know. So now we'll write calculation of area of triangle ADC. ADC. What's the value of A? 15. B 28. C 41. See, the triangle is ADC. So you need to take what are A, B, and C? The lengths of AD, DC, and AC. Anything can be AB. ABC, there is no order. No order. But what are the values of A, B, and C? The lengths of the sides of that triangle, ADC. So AD, DC, and AC. Done, children?
Yes, ma'am. Doing, ma'am.
Ma'am, I'm doing the last step.
Yeah.
Completed, ma'am.
Yeah. Class done?
Yes, ma'am.
Yeah. So children, it's very important to make the diagram, So remember this angle between the first two sides is a right angle. If PQRS is the quadrilateral, the first two sides are PQ, and write down all the sides PQ, QR, RS, and SP. So PQ and QR are the first two sides. If the angle between the first two sides is the right angle, then PQ, QR, this is 90. Sometimes the angle between the last two sides will be a right angle. The last two sides, that is RS and SP. The last two sides are RS and SP. The first two sides are PQ and QR. RS and SP are the last two sides. Accordingly, you will have to insert the right angle. Otherwise, it's a very simple question. So we have to connect one of the two diagonals. If you connect the diagonal BD, you will disturb the right angle. So we join AC. Now you can see two triangles. One is a right triangle whose area you can find using half base into height. The other is a scalene triangle. We know all the sides. In fact, we find one of the sides using Pythagoras theorem. So now we know all the three sides and we use Heron's formula to find its area. The sum of the areas of the two triangles, the areas of the two triangles put together is the area of the quadrilateral. All right, children?
Yes, ma'am. Yes, ma'am.
Any doubts? Any questions you have? Any different way? All right. 30, no, sorry, not 40, 30. So an alternate method can be, you can find the area of triangle, ABD. You can find the area of triangle ABD, then find the area of triangle BCD and add both to find the area of the quadrilateral ABCD. This is the area. This is the formula to find the area of a quadrilateral. Given, these information. Given, information like this, then you can use the formula half D into H1 plus H2. That is half diagonal into the sum of the altitudes falling on that diagonal. Half diagonal. Here the diagonals are BD and AC. The diagonals are BD and AC. Half into diagonal BD into the sum of the altitudes on the diagonal BD. The sum of the altitudes on the diagonal BD. If you take the diagonal AC, half into AC into the sum of the diagonals on, sum of the altitudes on the diagonal AC. And we have information, given here in the question that meaning whatever information is required in the formula, all that is given to us. So we can use this formula. You can also find like this. You can find the area of or you can find the area of triangle ABD. What's the area of triangle ABD? Half base into height. Half base is BD into height is AL. The altitude on BD is AL. So half into BD is 64 into AL is 16.8. You should find this. Then you must find area of triangle BCD. How? Half into base BC into height CM. So half into BD is again 64 into height CM, which is 16 point, not 16.8, 13.2. And add both. You can also do it like this. This is one method, or you can also do it like this. Find the area of the two triangles using the formula half base into height and add. Find the sum of the areas of the two triangles and that will give you the area of the quadrilateral. All right, children?
Yes, ma'am.
Yes, ma'am.
All right. Anybody still writing? Please tell me. I'll wait. Okay, all of you have finished. We'll just all say are in centimeter, okay? All units are in centimeter. Thirteen, the 169. $69. The only one thing I want to say is about the calculation here. So you can either do 26 square is 676, 24 square is 576, or 676 minus 576 is 100. Okay, that way. I've used the identity a square minus b square is a plus b into a minus b. A square minus b square is a plus b into a minus b. 26 plus 24 into 26 minus 24. So 50 into 200. Anyways, you can work. 26 square is 676. 24 square is 576. So 676 minus 576 is 100. You can do that anyways. And then to find the area of the triangle BCD, it's very clear it's an equilateral triangle because all the three sides measure 26 centimeters. So even if you use Heron's formula, you will get the same answer. Supposing we don't realize it's an equilateral triangle and we find the area using Heron's formula, you will get the same answer. Exactly the same answer you will get. But we are not using the Heron's formula because you can, this is time, you can save time using this formula √3/4 into side square because it's an equilateral triangle. So one is a right triangle. So first analyze the triangles, whether it's an equilateral triangle, right triangle, or a scaling triangle. And then see what information is given. If base and height is given, you can use the formula half base into height. If base and height is given, you can use the formula half base into height. If it's a right triangle, half base into height. Equilateral triangle, √3/4 into side square. If it's a scaling triangle and you know only the three sides, you don't know the altitudes, then use Heron's formula. However, you can use Heron's formula to find the area of any triangle. So like this here, this equilateral triangle, if you find the area using Heron's formula, you will get the same answer. Okay, so the area of so one is a right triangle, ABD is a right triangle, half base into height is the area, and BCD is an equilateral triangle, √3/4 into side square. To find the area of the triangle ABD, we do not know the base AB. So we find that using Pythagoras theorem. Then find the areas of the two triangles, add to get the area of the quadrilateral. Perimeter is only the sum of the four sides. It's a quadrilateral. The sum of the four sides, you should not add BD. Because there is BD in the middle, you should not add BD. Perimeter is the sum of the four sides of ABCD. ABCD is a quadrilateral. So it has four sides. They are AB, BC, CD, and AD. Find the length of these four, add the length of these four sides. That's the perimeter. You should not add BD because there is BD, that line segment there. You should not add that. You should not get into the figure at all. You should not go into the figure. You should go only along the boundary. See, supposing you start here, go along the boundary, walk along the boundary. AB plus BC plus CD plus DA. See, you come back to the starting point. That's all. That is the perimeter. You should walk along the boundary of the closed figure. You must go along the boundary of the closed figure. Done, all of you?
Yes, ma'am.
Completed, ma'am.
Yes, ma'am.
Everywhere the unit is centimeter. Everywhere the unit is centimeter. Yes, Krishmika. Krishmika.
Ma'am,
Yeah, tell me. How do you find BC in triangle? Okay. Oh, sorry, I didn't mark one important information. Yeah. Yeah, Krishmika, tell me, how do we find BC in right triangle ABC?
1 minute, ma'am.
Arjun? Arjun? Are you ready, Krishmika?
Yes, ma'am.
Yeah, tell me.
BC square plus BA square.
BA square, huh?
Yes, ma'am.
Which is the hypotenuse?
AC, ma'am.
AC is the hypotenuse. Okay, which is the right angle? Where is the right angle? At C, right?
ABC, ma'am.
ACB. ACB is the right angle. Which is the side opposite to the right angle?
AB, ma'am.
That is the hypotenuse.
Yes, ma'am.
Which is the side opposite to the right angle? I'm asking you again. Which is the, okay, name the right triangle.
ACB, ma'am.
Okay. And angle C is 90 degrees. Which is the side
Yes.
opposite to the right angle?
AB, ma'am.
That is the hypotenuse.
Yes, ma'am.
Okay. Now tell me BC square plus?
AB square.
No, you should write the hypotenuse square separately. You must write the hypotenuse square separately. Is equal to AB square it should be.
Yes, ma'am.
So BC square plus?
AC square.
AC square. Now tell me for this triangle. Tell me how will you apply Pythagoras theorem in this triangle? Which is the hypotenuse?
QP, ma'am.
Q?
P.
Okay. Which is side opposite to the right angle?
PQ.
No, this is the right angle. Which is the side opposite to the right angle? Which is the side opposite to the right angle?
PQ, ma'am.
No. QR. Okay, where is the right angle? It's at P, right? Leave that letter. QR is the hypotenuse.
Okay, ma'am.
Yeah. So the right angle is at P. Leave that letter P. QR is the hypotenuse. In this figure, angle C is 90 degrees. So leave that letter C. AB is the hypotenuse.
Okay, ma'am.
Yeah, now write QR square separately is equal to QR square.
Yes, ma'am.
Square the hypotenuse and write it on one side is equal to, now tell me, is equal to?
PR square.
Yeah.
Plus PQ square.
Yeah. Tell me in this triangle. Tell me Pythagoras theorem in this triangle.
XY, ma'am.
Yeah, now I'm not helping you. Tell me the result. Tell me the equation.
X is its square plus is it y square is equal to xy square.
This is how Pythagoras theorem works. Okay. All right. Yeah, now you can continue working.
BC square plus 17 square,
No, AC is 15.
sorry ma'am, 15 square is equal to 17 square. BC square is equal to 17 square minus 15 square.
Okay, no problem, Krishmika. You can continue writing. You understand from the way I work, and you can ask me your questions.
Yes, ma'am.
Yeah.
Ma'am,
Yeah.
ma'am, I got the answer for the last as 104 centimeters square, ma'am.
Yeah, 1 second. 104. Let me see. Yeah, area is 104. Correct. Very good.
into 6. ఇదేదండి అని చాలా ఉంటా Ma'am, I have one doubt, ma'am.
Yes, Danya.
Yes, ma'am. Ma'am, actually 60 plus 54 is 114 only, no, ma'am.
Oh my God. Where, darling?
Ma'am, actually I'm talking about area of the quadrilateral.
Oh, okay, okay. 104, no? 114. Oh, Sanjay said 104, right?
Yes, ma'am.
Oh, sorry. Okay, it's 114. Okay. The answer, I have 114 only. Correct. Sorry. I overlooked the answer. It's 114 only. Sanjay, I think you got. Yeah. Sanjay, I think you got 60 and 54. You didn't add it correctly.
Yes, ma'am.
Yeah. So I've written 18 as 9 twos are 18. I've written 9 as it is, and 6 as 2 threes are 6. 3 as it is. So 2 nines, 2 twos, and 2 threes. Is it over?
Yes, ma'am.
Ma'am, 1 minute, ma'am.
Yeah. Yeah, done? Madhumita?
Yes, ma'am.
Perimeter is the sum of the four sides, AB plus BC plus CD plus AD. AB 17, BC we found, right? 8, CD is 12. What's the perimeter? Yeah, 46 centimeter. This is your homework. Done, children?
Yes, ma'am. Completed, ma'am.
Yeah.
Yes.
All right, children. I already told this in the last class. Read and tell me if you understand.
Yeah.
See, every isosceles triangle need not be right. Every isosceles triangle need not be a right isosceles triangle. So in an isosceles triangle, we know two sides are equal. Base is not any of the equal sides. It's the third side. If it is a right triangle as well as an isosceles triangle, if it is a right triangle as well as an isosceles triangle, that is a right triangle in which two sides are equal. If it is a right triangle in which two sides are equal, right isosceles triangle or isosceles right triangle, whatever. So there are two things there. It's isosceles, so two sides are equal. It's a right triangle, so one angle is 90 degrees. But we know that in an in a right triangle, the hypotenuse is the longest side. In a right triangle, the hypotenuse is the longest side. So it cannot be equal to any side. Hypotenuse cannot be equal to any side of the triangle because that's the longest side. So the legs are the equal sides. I told you what the sides are called in a right triangle. In a right triangle, this is a leg, this is another leg, and this is the hypotenuse. Legs are the sides that contain the right angle. Legs are the sides that contain the right angle. In general, any right triangle, these are the legs of the right triangle, and this is the hypotenuse. Now, when it is an isosceles right triangle, the hypotenuse is the longest side. It cannot be equal to any side. So the legs are the equal sides, and this hypotenuse is called the base. Because what is the base? Not any of the equal sides. So the hypotenuse is the base, and the equal sides are the legs. Is it fine, children? Understood?
Yes, ma'am.
Okay, so in an isosceles right triangle, the base is the hypotenuse. Base is the hypotenuse. And the equal sides, because it is an isosceles triangle, the two equal sides are the legs, the two legs. Okay. Okay. Yeah, now I have to clear this. So you don't rub it. I just want space, so I'm clearing it. Did you make a note of this, children, all of you?
Yes, ma'am.
Okay. You don't erase it because I'm erasing, you don't erase. Actually, you don't even have to find x. I'll tell you why. It's enough if you find x square. Here, it's enough if you find till here. You don't even have to find x, because what's the area of the triangle now? Area of triangle ABC is equal to half base into height. Half into base BC into height AB. So that is half into x into x. So it is half x squared, half into x squared. So we already know x squared is 450. So half into 450. So 225. Actually, you don't have to compute this, is what I'm trying to say. You don't have to find this. Because anyways, area of the triangle is half base into height, which is half x into x. X into x is x squared. And x squared is 450. So 225. Even if you use the value of x, you will get the same answer. Is it over, children?
Yes, ma'am.
Completed, ma'am.
All right. So the base is given, base is the hypotenuse. We do not know AB and BC, they are the equal sides. So we'll say let AB equal to BC be equal to x centimeters. Then we can only use Pythagoras theorem to create an equation, to construct an equation. We can only use Pythagoras theorem. Now we need to construct some equation and work and find x. We need to construct some equation, work and find x. And since it's the right triangle, we use Pythagoras theorem. So on working Pythagoras theorem, we get x squared is equal to 450. We've also found the value of x, but which is not needed. Then you know area of the triangle is equal to half base into height, x into x, because base height both are equal to x centimeters. They're the equal sides. X into x is x squared is 450. So half of 450, 225 centimeters squared. All right, children. Any doubts?
No, ma'am.
Okay. We'll substitute and find the value of 4 root 2. Value of root 2 is 1.414. You can round this off to 5.7. So here the area is given. Area is given. Again, it's a right isosceles triangle. Area is given. So you can construct an equation using area. Half base into height is equal to area. See, the idea is to construct an equation, work and find the unknowns. That's the idea. You need to see when the question is find perimeter, you cannot directly find the perimeter. We don't have any information to find the perimeter. To find the perimeter, you need AB, BC, and AC. We know none of them. So the idea is to construct an equation, work that and find the values of the unknowns, AB, BC, and AC. So what equation can you, so when the question is find perimeter, you cannot directly find the perimeter. You have to get all the information needed to find the perimeter. So how do you get that information which is needed to find the perimeter? For that, some information is given. Area is equal to 8. So you'll have to construct an equation using this 8 centimeter square. So half base into height is equal to 8. Base and height are the equal sides. So half into x is equal to 8. So when you work this, you can get the value of x. So they are the equal sides, AB and BC. So you found AB and BC, 4 centimeters each. Now using that and using Pythagoras theorem, you can find AC, which is 4 root 2, or 16 plus 16 is 32 children. You can write 32 also. You can write 32 square root of 32, you will get 4 root 2 only. You can also write 16 plus 16 is 2 into 16. 16 plus 16 means 2 into 16. So square root of 2 into 16 is, square root of 16 is 4, 4 root 2. 2 remains under the square root, 4 root 2. And root 2 is 1.414. The value of root 2 is 1.414. When you multiply, you get 5.656, round it off to 5.7. So like this, we have found all the 3 sides. See, none of the sides were given. Only area was given. Using that information, we constructed an equation and we found x, which are the equal sides AB and BC. And then using Pythagoras theorem, we found AC, which is the hypotenuse. Now we have the 2 sides and the hypotenuse. You can find the perimeter. Is it clear, children?
Yes, ma'am.
All of you? Clear, all of you?
Yes, ma'am.
All right. We'll do this and wind up the session for today. All right, children. So here we are given the equal sides as A units. To find the perimeter, you need the hypotenuse. You need the length of the hypotenuse. You know, two sides are A units. Two sides are A and A. So you need to find the third side AC. And that we find using Pythagoras theorem. So once you find that, add the length of the three sides to find the perimeter. So root of 2A square. Root 2 remains under the square root. A square comes out as A. A square comes out of the square root as A. Root 2 remains under the square root. So root 2A units. AC is equal to root 2A. Now perimeter A plus root 2A. A plus A is 2A. Plus root 2A. You can take out A common. So you'll get 2 plus root 2 in the bracket. So 2 plus root 2 of A units. You can, use the value of, if you want, you can continue like this. If you want to continue, you can do this. What you can do? So that's, you can continue like this. That is equal to 2 plus 1.414 A, which is 3.414 A units. You can use the value of root 2, 1.414. You can do it here also. You can do that here also. 2A plus root 2 is 1.414 A. So 2A plus 1.414 A is 3.414 A units. All right, children, it's time for my next class. If you have not finished, take a screenshot. Yeah. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you.